Right. Good day, everyone. Welcome to the IEEE Region 8 Action for Industry webinar for the month of May. This month, it is our pleasure to host the very active and very engaged industry engagement team from the IEEE Italy section, as well as our very esteemed technical presenters who are also from Italy. The format of this webinar is based on presentations followed by question and answers. And the question and answers will be open, so participants are more than welcome to add any questions in the chat, or they can add it, basically raise their hand up and unmute and ask a question as well. The three speakers that we have today are Tiziana Tambosso, who is actually part of the Region 8 as well. She's the Vice Chair for Technical Activities for IEEE Region 8. She is also a member of the IEEE Industry Engagement Committee. And in her professional role, she's an innovation consultant and an entrepreneurship mentor. She'll be giving a broad overview of IEEE Italy Section Action for Industry Engagement. Our next speaker will be Danilo Pau. He has 32 years of experience with STMicroelectronics in System R&D. He has 109 invention requests and 151 patent applications. He is a fellow of IEEE as well as of other bodies. And he will be covering edge AI solutions and the transition to generative AI. Our speaker after that will be Laura Falaschetti. She is an assistant professor at the Politecnico University of Marseille in Italy, and she teaches over there architectures and programming of digital systems. She will be covering smarter devices, faster decisions, the actual edge AI. Thank you for our speakers for joining us today. Before we proceed further with the presentations, just a quick overview from an IEEE Region 8 Action from Industry perspective. Industry members traditionally have been the majority of the membership of IEEE and very important contributors. And they still do remain very important contributors to IEEE, but the percentage of industry members compared to members from academia and elsewhere has reduced. Region 8, as well as our Global Industry Engagement Committee, are making very clear and focused measures to support our sections to engage industry more, provide value to industry, and also essentially a two-way conversation, engage industry in IEEE activities as well, so that we can learn from the work they are doing and they can take advantage of the resources as well as the plethora of members that we have and the research we have. And this webinar is part of those efforts. I will stop sharing my screen over here and invite Tiziana to please present your screen and begin the presentation.
Thank you, Sohaib, for the presentation. And you already introduced me, so it's easy. I will go to the structure of Italy Section Industry Relationship Committee that is chaired by a coordinator. Then in the members, we have the past coordinator, Bernardo Tellini, that was also past chair of Italy Section, and some industry partners. Also Danilo is a part of this team, and young professionals. The main goals of this committee, main goal is to move Italy Section closer to industry by organizing special events and also promoting some awards that we will discuss later in more detail, and other programs in order to strengthen the relationship between Italy Section and industry, and also increase the awareness of IEEE Region 8, but also IEEE for industries. And main activities can be summarized in these points. The first activity, the most important, is the organization of industry workshop and panels during main events of Italy Section, sometimes conferences, but not only, and support the organization of IEEE ATSI Forum, that was a conference started by Italy Section that now is a portfolio conference of Region 8. Then we support our industry members in their elevation to IEEE Senior Member Fellow. That is also important to maintain the relationship and also the engagement of our industry members with the IEEE. Organize meetings with industry, new industry, to illustrate IEEE initiatives and so engage more industries. Advertise IEEE initiatives, and among them milestones program that was really interesting for some industry. We have here an example of ST Microelectronics that already has obtained 2 milestones from IEEE. And promote competition with awards sponsored by industry, competition for students, but also young professionals and startups. And promote Italy Section Industry Distinguished Lecturer Award, introduced in the section since 2017. Organize job fairs during the Italy Section main conference, and also advertise all the initiatives of IEEE Region 8 Action for Industry, like the internship program and the mentorship program. And regarding the section Industry Distinguished Lecturer Award, that was introduced more than 8 years ago, and was very effective in promoting the cooperation between industry and the IEEE Italy Section. We have some awardees that are very important people, like Benedetto Vigna, that was the one that was awarded with this in Industry Distinguished Lecturer, and at the time was a director of ST, but now is the CEO of Ferrari. And is a lecture that was given at least in 3, but usually 5 places in Italy, invited by chapters or student branch chapter, was really well a success of participation. And then after that, we have many others from also important industry, a big industry like ABB, TIM, and also Enel and Terna, that are the main operators in Italy, of energy operators. This program, very effective, have continued to be supported and well participated. Then we have some financial support from industry for competition with students. For example, since 2017, we have every year a master thesis award promoted by ABB and a PhD thesis award. And this is an example of the ceremony during ATSI. And we have also other awards, competition promoted during our events. This one was, the last one was during ATSI, and there was a competition with the young professionals supported with an award by ST Microelectronics. An important event started by Italy section that became so important that was adopted by Regionate as a portfolio conference is this Research and Technology for Society and Industries, a forum that plays not only a conference, technical conference, but a place for networking and exchange of experiences among different stakeholders coming from the research, so academia, research centers, but also coming from government and the big, small and medium and also startups. For each of these stakeholders, special events are organized in order to make the experience quite unique. And industry are involved like keynote speakers or plenary speakers or in industry panels and workshops, or they suggest the topic of a special workshop or panel and support competition, as I said before, or they can give tutorials for professional engineers and students. And also we involve a professional association of engineers during this conference that increase the number of professional engineers, not only researchers, that participate to our special events. And also job fair and workshop in local languages can be part of this event. And these are the events organized during ATSI 2024 in cooperation with the Region 8 Action for Industry. The first one was an industry workshop, and the second one was in cooperation with the company, ST, on humanoid robotics. Interesting, a spin-off of this event, thanks to the organization of this workshop on human robotics, we have the special opportunity to cooperate with this big trade show that is SPS Italia, with more than 40,000 participants and more than 800 exhibitors. And in that occasion, SPS was one of the financial sponsors of ATSI 2024 and invited us to organize a panel. And I was the organizer of another panel on humanoid robotics. It was in Italian because the fair was in Italy. And we have the participation of three big companies, ST, PAL Robotics and Oversonic Robotics, and also Italy section in a very participated final around the table. And with that, I will conclude my presentation. Thank you, and I'm available for questions.
Thank you so much, Tiziana, for this. Seems like a lot of activities and engagement happening in Italy section, and this is especially very motivating for the other sections, I'm sure, as well, as these are conducted. and shared. What we'll do is we'll take the questions at the end, if you're okay with that,
Yes.
and we'll move forward to our next presentation, which is by Danilo Pau. Danilo, please share your screen. Your presentation will be on Edge AI solutions and the transition to generative AI. I believe you're still on mute, Danilo.
Okay. Thank you so much for inviting me. I'm super happy to be part of this day, and thanks Sohaib, and thanks to the Region 8 Action for Industry and the Italy section for giving me this opportunity essentially to share from an industry point of view what's going on AI, with particular emphasis to edge AI. And you know, ST is an independent device manufacturer, so I think it's going to be interesting, I hope. And therefore, about my talk, let me share some motivations first. So I will speak about the term fixed AI and how did it pop up, and what was the impact on the industry about fixed AI. Then it generated a challenge, and the challenge I called heterogeneity challenge. And I will elaborate what does it mean and how a silicon manufacturing industry like ST addressed it. Then there is a transition which is going on, and is about generative AI, which is generating an unprecedented digital divide and the associated gap. I will substantiate that. And then I will share some more information about how the transition from fixed AI and some early solutions can solve and can give an hope with respect to this unprecedented digital divide gap. So let me enter on the fixed function AI. We all know that 2012 was a special year because AlexNet from Alex Krzyzewski, a PhD of Geoffrey Hinton, with AlexNet, won the Image Large Scale Visual Research Challenge. And from that period on, only neural network approaches were top performer. And this gave the opportunity to many researchers to devise other more complex pipeline. And when I say fixed function, it means fixed amount of weights after training, fixed function in terms of task to be accomplished. These are reactive systems in the sense that they receive data and produce raw data from sensors and produce metadata. But the interesting thing was that from 2012, I would say onward, 2019, there was the memory opportunity. And the memory opportunity is the gap between the memory assets of GPU, single GPUs, and the model footprint of these neural networks, ResNet and the others that came after. So people could play with enough memory because GPU were making this available, and therefore the gap also reduced over the time, at the point that the industry on 2017 realized the potential in services which were able to create revenues by placing AI in the cloud, where essentially unlimited resource assets, computational storage, were available. So services were AI services with respect to pre-trained neural networks and supervised learning, came in service. But at that time, it was already clear that services could not scale. For example, on 2017, Google realized that automated speech recognition would imply doubling the assets for the Google Cloud. But the evidence was also from the small medium industry, because these services costed so much that some small enterprises could not afford. Fortunately, the community addressed this challenge by forming a community called TinyML. We as ST, we were a first-day citizen and partner of TinyML, but TinyML essentially federated all the industry and the researchers which wanted to move workloads, AI workloads, to the edge. And then, since then on, up to the current days, we have seen a proliferation of programmable products, such as microcontroller, and dedicated product with hardware acceleration, for example, the neural processing unit. And as industry, what we see, both as ST and other industries, these products will proliferate even more in the next year. So, which is important because, you know, industry realized that tiny machine learning could generate stream of revenues, which motivated investment and created a positive loop. What does it mean? What did mean TinyML? Tiny resources, limited amount of memory, computational complexity, with very limited power consumption. TinyML objective was targeting device under 1 milliwatts, but at the same time with high accuracy, because there is no reason or no usage for algorithms which are poor in terms of accuracy. But there are a lot of optimizations technique and as well techniques to devise neural networks, such as knowledge distillation, hyperparameter optimization, neural architecture search, quantization, pruning, and so on and so forth, which helped and are helping machine learning designers to devise tiny workloads, which anyhow can take advantage of the fact that sensors do not generate floating point numbers, but they generate integer numbers, depending on the type of sensor, or fractional arithmetic if we also consider some sort of preprocessing. No sensor generates floating point numbers, so why do we need neural networks which are in floating point? There is no need. So a lot of optimization, thanks to post-training quantization, quantization-aware training, can be introduced in order to lower footprint, speed up inference rates, and so on and so forth. But the community didn't want, due to the proliferation of hardware devices, to uncraft these neural networks, which were and are devised depending on the application, depending on the task, depending on the sensor, and so on. And therefore, automated deployments were necessary, were required in order to increase the productivity. And what are the edge assets? Essentially, three types of assets. The sensors. Sensors are not even more a simple acquisition device, but they have AI computing capabilities with very low amount of memory and dedicated instruction set. One example, one notable example, is the Intelligent Signal Processing Unit, which is a MEMS, gyroscope accelerometer, and a reduced energy programmable processor, which consume a few microwatt, all in a small package, 2.5 times 3 millimeters, so very, very small, time 1.7. So very, very small and power and ultra low power, in which for the very first time we can deploy at scale AI, also binary neural networks, because we have instruction set which support binary computation, multiply and accumulate. Another example, another assets are the microcontroller and the multiprocessors. These were the first assets targeted by the TinyML. Here we have more memory, for example, 1 megabyte of RAM, 2 megabyte of flash, more computational complexity up to 600, where also in the last period, neural processing unit were super integrated on the same die. And these also increased the computational capabilities. But this is not a single chip. This is a family of chips. For example, just to mention STM32 family of microcontrollers and microprocessor, we have more than 700 product number. So imagine the difficulty for an embedded system engineer to pick one of these and to program and maybe move on another during the lifetime of their AI project. Furthermore, actuators. Actuators are the one that essentially put in action decisions taken at embedded processing level. And here ST did a family of devices, considering that, as Tiziana said at the beginning, ST was recognized by the IEEE milestone program for devising the bipolar CMOS, DMOS super integrated silicon manufacturing process since 1985, which is instrumental to put on the same chip the power stage, the microcontrollers, and also bipolar transistors. And these have a huge impact on the automation industry, cars, robotics, and so on and so forth. But to deploy AI workloads, we need to cope with deep learning frameworks, which export intermediate representation depending on the type of deep learning frameworks, which do not interoperate with IDEs, which essentially are a plethora used by embedded system designers. And these tools understand C code, which is not exported natively by the above mentioned deep learning frameworks. And there are, depending on the problem to be solved, the application engineer select sensors, real-time operating systems, and maybe there are a plethora of neural networks which coexist on the same IoT device because of the heterogeneity of solutions that can be devised to solve a certain problem, depending on the sensor. And then, as I said, there are also too many several hundreds of devices, just mentioning the ST one, but if you consider also the other industry, then these are several thousands of devices, including also the microcontroller for automotive. So you understood, here the keywords and the key challenge is heterogeneity. How to make dealing with all of that very productive and automated. Just to let you have just a flavor of the problem, take the operators. The operators are the layer on which the deep learning engineer compose neural networks. So you have pooling operators, convolutional operators, different type of convolutional operators, recurrent layers, non-linearity, mathematical operators, layers to manipulate the tensor shape, and quantizer. All of that, and I'm being very conservative, 400 operators. And then there are other problems, different topologies, and so on and so forth, on which to build this operator. So you understand how difficult, impossible, too complex, and crafting all of that for thousands of microcontrollers. Quantization, as I said, is very important because sensors do not generate fixed or integer numbers. So we need to quantize, which means to move from 32-bit floating point to integer arithmetic, 8 bits, 16, 1 bit, 4 bits, depend really on the problem to be solved. But just considering the following possibility, all in floating point, weights, input and activation, input and output, or binary, or a mix of floating point and binary, or a mix of integer and binary. We have 27 configuration, and these are exploding because 4 bits computing and 1 bit computation, especially in generative AI era, are going to be used, and therefore the number of hyperparameters to compose a neural network will certainly and is certainly increasing. So you have different paths to deploy your neural networks exported in ONX, in Keras, in TensorFlow-like intermediate formats, to all of these plethora of heterogeneous devices. What was our solution? To devise only single technology called ST core technology, essentially, which replaced the work of thousands of engineers, which were meant to handcraft these solutions, and in C, for example, and essentially the unified core technology does that for all the people. And it's a free technology. Everyone can download over st.com, and does also another thing, not only generate C code, but also validate. Because people want a process which is essentially lossless, in the sense that the accuracy achieved by training neural networks has to be on par, the same, of the C code generated. So model validation is also another important asset, and also profiler. The profiler also give back information to the developer about the complexity, the runtime complexity, and all in detail, layer per layer, network by network, which are fundamental, essentially to change the paradigm in developing a neural network. But then, through the developer cloud, this technology is immediately developed. You go on the developer cloud, you register, and you get access to a cloud, which is essentially a bunch of off-the-shelf computers, where the added value is that we attached real hardware, real boards that you can buy. So if you don't want to buy these boards, but you want to attach your, you want to be aware about the complexity of your AI developments, voila, in a minute you can be aware about the multiplier, the accumulate, RAM, ROM, the footprint on the device, and the latency. And that's not a bunch of emulators. These are real boards, and these lift the productivity really quite much compared to what was possible in the past. And all this technology helped very much the product proliferation. One product that I would like to mention, I'm not selling anything, but I would like to demonstrate how years of innovations that we put on this subject on Edge AI were capitalized, for example, on STM32N6. Three things makes this solution very relevant. A Cortex ARM 55 at 800 megahertz with vector instructions, and a neural processing unit, which is as efficient as 3 teraops per watt. Just to give you a flavor of that, my GPU back on 2014 was 5 teraops, and it was the GeForce GTX 985. It costed $500 with pipes, cooling mechanism, and so on. And now you have such a product, such equivalent computational equivalent product on the palm of your hand without any particular cooling mechanism, and which enables everyone to develop great solutions. And as example of performances, interactive rates for YOLO V8 people detection, 26 frames per second, leveraging the embedded memory of DEN6, the pose estimations, and also the palm detector plus landmarks. So you understand that all of that technology can really enable to build up more sophisticated vertical applications.
Style.
But the
What
one
makes
that I
us
like
stand out
quite
globally
much are
is
these
our
smart
pioneering
glasses.
work in the field
These have
of
been
ultralight
developed
consumer-level
by,
AI glasses.
Meta
These
Pau,
glasses are the optimal hardware for
Chinese
artificial
company,
intelligence
and
generative
with
content,
N6 they
redefining
put
the next
on the
generation of
glasses
information
in order
display
to
and
realize
interaction.
to
This
provide
groundbreaking
augmented
innovation
reality.
enables
And I
users
think
to not
this
only
is
enjoy
a
a
super
full-phenomenal
nice
intelligent
solution,
experience, but
because
also
it
all they
proves, among the other
provide.
things, on top of the application, really that Edge AI ultra low power in solutions like the N6 can enable unprecedented application and user experiences. But then we are living in a transition, and the transition is due to the generative AI. But generative AI created an unprecedented digital divide back to even greater than the one we experienced on 2000. On the left, you see a few companies which are listed at artificial analysis website. And if you see the name of this company, these are in US, essentially, few in China, and just one in France. And these are the top, but if you restrict to the top one, which are providing very high level of artificial intelligence index as defined in this website, essentially, these are only US company and also a Chinese company. So only two countries are mastering the AI with closed system, with open systems, but everyone else is not capable to devise such a solution. Why that is possible? Well, the investments are so huge, we are reaching hundreds of billions of dollars, which are not in the possibility, for sure, of industry with lower market capitalization, which is impossible to achieve to small, medium enterprises, and that's substantiated the digital divide. And then if you see also the evolution of these models, Gemini, DeepSeek, different type of GEMA solutions, they are really lowering the barrier to make this system available and to be pervasive as much as possible. But then these are really a remunerative system for cloud companies. Like it was happening on 2017 on fixed AI. The situation has been reproposed under the memory wall. What is the memory wall? It's the gap between over-parameterized trillion weights models to the capability of modern GPUs, which means that we need thousands, hundreds of thousands, even millions of GPUs in a compute server, in a compute center, to retrain trillion weights neural networks with hundreds trillion tokens. So how can we afford, as everyone else, excluding those companies, to afford that? Clearly, the only possibility which is left to us is to type prompt. And that's really a poor return for every, and also the research will be affected because it's been privatized to few companies. Companies that can design a processor such as the Grasshopper, 2 kilowatts, peta computing, 4 bits, 8 bits, with both multiprocessors and GPU very tightly coupled with an half of trillions of transistors. Such capability really, it's affordable only Grasshopper to NVIDIA, clearly. But what to do with Grasshopper? If you couple with Colossus, then you build up a huge compute center, which next generation will be with millions of GPUs. Who can afford it? No university in Italy, at my knowledge. In Europe, we are out of debt completely. There is no hope. And even that, this is very affecting our planet because the assets are unprecedented. As I said, hundreds of trillion token data set. So you can imagine how much work has to be done at only dataset level to prepare such, to prepare the right data to train such trillion weights neural network, which demand gigawatts nuclear reactors. For example, 3 Mile Islands will be reopened in US. There are hundreds of billions of investments, and nuclear reactors will power up the next generation of compute servers. the electricity price, the bill, hundreds of millions to train generative AI workloads, the amount of water which is required to generate kilowatt per hour nuclear energy is creating an unprecedented impact on the natural resources of the planet, will be generated tons of e-waste on the 2030, and CO2 will be increased, has been increased already by double digit. And so that's not sustainable. And I don't believe service will scale up. There are 5.16 billion Android iOS users already in 2024. It's impossible to develop query-based GenAI for all of that simultaneously, which will require several tens of thousands of compute servers, which will have a huge impact on the planet. So there is no solution then to change completely direction, to reverse the direction. And as semiconductor industries, including ST, are required to contribute to the U-turn. And the U-turn is bring the generative AI at the edge and completely change the perspective from cloud-based to edge-based. And in fact, you know, since 2014 and 2017, thanks to the work of Young Goodfellow and Google about transformers, then generative AI has been successful at research level. But then the TinyML community last year understood that we as community, because ST is also inside, needed to evolve, and then rename itself as Edge AI Foundation. We are leader partner of it, and we are strongly contributing. Myself is the leader, the chair with Professor Ajar Musanif of the Edge AI working group. And therefore, we are making our best efforts to contribute to reverse the scheme. So, for example, I wondered to myself, but are there already deployments at the edge about GenAI? And so we published a paper, me and Gloria Giorgetti, a student of mine, by looking at the papers, 135 published in the last 3 years, 2020, 2022, 2024, trying to understand which GenAI approach were really implemented at the edge, not claimed to be possible, but proven to be implemented at the edge. And in fact, the majority were implemented in application processor embedded in smartphone, while few on Raspberry Pi Jetson, and very few on microcontrollers. The one on the microcontrollers, for example, were based on our processors, the STM32MP2 and the STM32N6. So that was our contribution, trying to change this situation. Also, 10% on Jetson Orin, but Jetson Orin require quite much power compared to the processor I just mentioned. And the majority on the smartphone were coming from US and Chinese company, which are providing silicon chips. So, I mean, in Europe, we are trying really to keep up with innovation and contributing to bring generative AI at the edge. Few examples to substantiate that. That was an example, a demo developed with FBK. FBK developed the style transfer. I remember Elisabetta Farella and Alberto Ancilotto. And with them, my colleague Alessandro Vaghi developed an application to run generative AI image generation with style transfers from paintings, styles, in real time, 10 frames per second on the STM32NX and 6. And this has been demonstrated also to embedded world. Then other functional implementation that I did on the dual cortex ARM 35 1. GHz in software, Open Linux, ST Open Linux. I was helped by Andrea Basso, and we reached some initial applications. Olama is a great open source project which allows to compile off-the-shelf and map off-the-shelf, Hugging Face neural networks. For example, QN 0.5 billions in an initial performances, which is not top performances, but it proves that can be done. It can be done. It can be done even faster in the coming years. And also, there have been a lot of efforts in reducing the complexity, the model footprint, especially of generative AI workloads. So deep quantization, 1 bit has been developed, and one example is the Microsoft BitNet, and with Andrea we compiled on 6, having interesting initial performances. But then, you know, the community is really pushing hard to develop low parameterized neural networks for generative AI. I would say in the envelope between 100 to few billions parameters. So these are not tiny, completely change the picture, and this also will have a profound impact of the implementations in the coming years. And for example, DeepSeek has achieved as an open available model, has achieved a very good index, artificial quality index, which is elaborated at this link at Artificial Analysis AI. So it's interesting, and therefore, since it brings also reasoning capability, we have been trying to map on the STM32MP2, and we started to see interesting initial reasoning capability. But what to do with reasoning capability then was a question that came out to my mind. So we had short language models, and then with and without reasoning capability. But for what can be reasoning capability be useful? My answer is to a new form of a natural user-machine interface. So machine on which you can speak, and they can speak with you, as I'm doing with you, and get answers depending on your needs. And to
I feel cold in the house. Can you warm a bit the room?
Università di Genova, this initial demonstrator running on the Raspberry Pi, essentially with demonstrators is, let me just pause a bit, it's a demonstrator which essentially get your voice queries through Moonshine open source project, which has been released by Userful Sensor on GitHub. Then you get, it's a very light speech to text. And then with Granite 3.3 for IBM, we implemented the reasoning, and then through Piper, speech to text to speech, the answers. So the example is an intelligent tangent on which the thermostat has been transformed. I speak to the thermostat, because I have the needs to warm up my house. Then Granite query the web to understand what is the temperature outside my house, measure the temperature inside my house, and then generate some decision and actuate a plan in terms of warm up my house, depending also on my presence. So what you see, sorry, I go back on this video, is exactly this.
I feel cold in the house. Can you warm a bit the room?
Obviously is not in real time because there is no hardware acceleration.
Your room will start to feel warmer as I slowly increase the temperature by 2 degrees. I aim to reach a comfortable reference temperature based on today's forecast, ensuring we don't overheat. Would you like to provide any additional preferences, or should I proceed with these settings?
I'm out in a couple hours and I'll be back tomorrow morning. I want the home to be warm when I'm back, but I don't need to heat the house when I'm away.
Understood. I will maintain this temperature for your return, ensuring a cozy environment without unnecessary energy use. Enjoy your time out and rest assured, your home will welcome you with comfortable warmth tomorrow morning.
So that's not a mock-up. Actually, is a demo running on Raspberry Pi 5 through the software I mentioned. And unfortunately today, or fortunately today, there is no hardware acceleration, which open perspective for all the semiconductor industries such as ST and the others. So this is really the focus where we can and I think this gives a hope to us and to the European industry to address the digital divide I was mentioning before. But we are not alone. Let me also thank, because this work was done with the Università di Genova, Professor Riccardo Berta, and a student of mine, Pietro Firbo. But we are not alone, because this challenge, this digital divide, can only be solved if we act as a community. And there is a strong community which is in Europe, in US, which is really addressing edge AI, generative AI at the edge. And I am the co-chair with Ajar about the working group. Two forums have been already organized on 2024, and just on last 2 days, we organized the third forum. I strongly recommend you to hear the online recording, which will last 3 + 4 hours, and you will hear several contributions which substantiate the hope we all need. Otherwise, the generative AI will create a huge knowledge gap to many of us. With that, also, I contributed to the industry association EPOS and Inside in bringing up this hope, and you can see the report, you can read the report at this link, and I hope really also the Region 8 will strongly help us in educating the people on the hope, on the solutions, because we need to act as a strong, even interdimensional community. And I want to thank the IEEE Italy Section and the Region 8, because that hope has been substantiated today thanks to this invite. And any question, don't hesitate to write me or to ask. Thanks a lot.
Thank you so much, Danilo. This was a very insightful presentation. We'll take a question in the end, but thank you also for offering if the participants can reach out to you via email as well. That's very much appreciated.
Sure.
Our next speaker is Laura Felascati. Laura, please share your screen. She'll be presenting about smarter devices, faster decisions, the actual edge AI.
Okay. Can you see my screen?
Yes, I can.
Okay. So thank you for the invitation at this webinar, and thank you for introducing me, and also to introduce the title of this presentation. So smart devices, faster decision, the actual edge AI. And as you can see in the summary, in the outline, the presentation focused on the concept of edge AI and the reason for its relevance in a specific application, also industrial application, and followed by an in-depth examination of its implementation in selected use cases arising from research paper. Let us begin with some fundamental concepts closely related to edge AI. In electronic and IT, information technology, an embedded system is an MCU, a microprocessor-based digital system designed for a specific purpose, different for a computer servers that is programmed, designed for a general purpose. So unlike a general purpose computer, is not intended to be reprogrammed by the user and is often built on a custom hardware, software, firmware, integrated directly into the device it controls. Because its functions are defined during development, during the application, both hardware and software are customized for this specific task. And this lead to minimal hardware requirement, lower power consumption, faster processing, and reduced cost. This is the constraint in this field, in the embedded system field. In many cases, embedded system, the last point, operate in real time, ensuring predictable responsive time, and in general, are computing system tailored to perform dedicated task, the dedicated function efficiently and reliability. So example of embedded system that characterize and we commonly use it in everyday life includes home automation and all around home automation, so thermostat, air conditioner, biomedical equipment, measurement instrument, device for gaming, augmented reality, virtual reality industry, console, so all on. There are several devices that we commonly use in everyday life, and we doesn't know that inside them there is a microchip that work to this specific application, for a specific application. So a question: can this device, this embedded device, become intelligent, or better, in other words, can they go beyond the basic specific function and start performing additional tasks that actually support us in our daily life? For example, take a simple refrigerator. Besides controlling and stabilizing the internal temperature, what if it could also monitor its content with sensor camera and suggest what we need to buy for our next shopping at supermarket? Or think about a car. Beyond its core control system, fundamental control system, it could be equipment with sensor to detect pedestrian, the passage of a pedestrian, a rider, and provide real-time feedback to the braking system, especially useful if the driver shows sign of drowsiness. So the answer is yes, and we can make this possible. So embed the system with intelligent, artificial intelligence integrated by applying artificial intelligence directly on the device that collect, process the data. So the term edge AI, edge artificial intelligence, refers to the combination of two keywords: edge computing, that is when the data is processed near or on the device where it is generated the data, and artificial intelligence. So that is the implementation of artificial intelligence is computed directly on the edge device. In this way, the following statement is guaranteed: low latency in computation, lower transmission and processing costs, and greater IT security and privacy. This keyword, this key point, are stated also by Jeff Beer, founder of the Edge AI and Vision Alliance, that create the acronym BRARP. So bandwidth stands for bandwidth, latency, economics, reliability, and privacy. So analyze this single term because there are the key point of the Edge AI vision. The term bandwidth refers to the fact that if data processing is done directly on the device, and therefore there is no need to stream continuously data to the cloud and wait for a response, then bandwidth is no longer a concern for our application. The term latency is closely related to what we just discussed. Inference time, the time of inference, time of prediction is significantly reduced because the device doesn't have to wait for a response from the cloud. And in addition, they may be no network coverage in some area. So meaning that the response might not arrive or arrive with an excessive delay. So we strongly reduce latency working on directly on the device. The term economics refer to the fact that the edge AI algorithms are typically implemented on low-cost device based on MCU, eventually also tensor accelerator, but with low cost compared with the server or third-party cloud-based solution. And the term privacy, reliability, I skip the terms, reliability in the context of edge AI refer to the system ability to operate consistently and predictably in real time, even without network connectivity, while being robust to failure and requiring minimal maintenance over time. The last term, privacy, refers to the fact that due to the nature of this device, low cost, limited memory, and so on, data are acquired, processed locally, and then discarded to avoid memory overload. So moreover, since the data is not censored to external servers, there is a much lower risk of privacy being compromised, as it never leaves the device. So there are the key points. In edge AI, as I already mentioned, it is the combination of two buzzwords, edge computing and artificial intelligence. Edge computing means compute the data, process the data, elaborate the data at the edge, so near the network, the infrastructure. There are some benefits to being at the edge of the network. For one is where all the data comes from, and they can use a sensor to collect data based on what is going on around them, and can make decision on data locally and send it to other location, other device, and that device have access to data directly where they are generated or nearby. Regarding the artificial intelligence, is the terms that we already know, but edge AI comprise these terms. So the algorithm implemented into device are based on these kind of algorithm, particularly artificial intelligence is an overset because we have two subsets, machine learning and deep learning. And in this presentation, I focus on deep learning algorithms, so on neural network, on integration of a neural network on MCU. Resume summary about edge AI. So edge AI, as I already mentioned, it is a combination of edge device, edge computing, and artificial intelligence. So this is our link between the digital world and the physical world, and the more important point in bold is that instead of relying on a central server, we can make decisions locally. So no connectivity is essentially required. And if we still want to report information back to upstream server or the cloud, we can transmit just the final information, the important information, instead of having a continuous stream to send every single sensor reading, and that saves a lot of cost and energy. In this slide, I have reported some the connection between all these terms, so artificial intelligence plus edge computing that bring to edge AI, and sibling of edge AI is the TinyML, because first I mentioned the neural network. If we focus on porting neural network on tiny devices, so a device with a very low cost power, very low power, low cost, and memory constraint. So we talk about TinyML. So we prioritize ultra low power consumption. We realize models that are highly optimized and quantized with specifically technique, also today object of research, and we integrate this model on resource constrained device. The workflow is in part the same workflow of AI, because the first two steps are common, because first we need to start from data acquisition if we prepare a custom data set, or data loading if we already have a data set related to our specific application. But surely we need to make some adjustment to this data, normalization, processing, data augmentation, etc. The second step is the design of our architecture, and the training, the testing. And so in this point, we have a series of metrics to validate the accuracy, but other metrics, the validity of the network designed. And the third step is instead focused for edge AI, because is the difference between the regular AI and the edge AI, because the realized model, eventually quantized, compressed, or with the application of other techniques like pruning, etc., was imported into the firmware of the MCUs, of the selected MCU, and integrated into the microprocessing unit to have a device that incorporate an embedded system that incorporate an artificial intelligence algorithm. About the about the real use case for edge AI, I will make some example. From this slide, I reported some of the application for the edge AI. We noticed the versatility for this topic, because we can apply edge AI for autonomous vehicle, for smart agriculture, smart home, the word smart that repeat, smart industry, and also in healthcare. And in particularly, I focus on some research work developed by my research group, also in collaboration with a company like, for example, ST Microelectronics, and related for some of these tasks. The first task we take as an example is the field of smart agriculture. These are the publications related to this topic. The task that we implemented is an image classification, so using convolutional neural network that have been shown to be an effective network for the task of image classification, and with some modification in order to introduce a custom CNN into our system, into our edge AI system. So in particular, the problem we aim to solve is this. ESCA is a widespread grapevine disease that can reduce global yield by 20-30%, and early detection is critical for timely treatment and minimizing economic losses. So our proposed solution is a real-time image detection system based on a high-performance convolutional neural network, CNN, deployed on a low-cost, low-power embedded platform. To meet the constraint of this edge device, we developed a low-rank, we call it ALR net, the low-rank net, that is a compact CNN architecture using a technique of tensor decomposition and trained on a dedicated data set containing this kind of image. This is an healthy leaf, and this is a leaf affected by ESCA disease. This net was implemented on Python programmable machine vision camera called OpenVCam H7 Plus, based on an STM32 microcontroller ARM Cortex M7. Experiment result demonstrate that this network outperformed the state of the art, both for inference time and for memory efficiency. So the system is this. So we mount this image sensor on a tractor. The input, the video stream is processed by the MCU, and into this MCU we integrated the network. This is the first implementation of the network, the full rank network, then decomposed by the Candy-Cam Parafac CP decomposition to obtain a network, a lightweight network with the addition of a fine-tuning to adjust the final accuracy, and so we obtained the final model integrated directly into the MCU to have a real-time response. So the contribution of this research reported in the paper is fundamental, analyze the various technique, the various tensor decomposition technique. Tensor decomposition is the equivalent of FVD for tensor in pure thing. Is a higher order extension of a singular value decomposition for matrices. So reduce a tensor to a low-rank tensor that requires the reduced number of data and operation to be represented by preserving accuracy. So in this work, we analyzed different tensor decomposition technique, the Candy-Cam Parafac CP tensor decomposition, the Tucker decomposition, the TSVD decomposition, level 1 and level 2. And we make this analysis on 3 well-known data set in literature and also on our custom literature. And in all cases, we noticed that the approximation error related to the compression factor bring to a CP decomposition as the winner of this comparison. So we choose this kind of decomposition to apply for applying to our custom network, and decompose this technique, decompose the convolution layer and the dense layer into there is a figure, okay, so we apply this decomposition for convolutional layer and fully connected layer. Convolutional layer is decomposed as 2 1 by 1 for one convolution at the input and output end, and a white convolution in the middle. So is the starting layer and then the decomposed layer, and the same method is applied to decompose the dense layer. So this is the initial architecture, and this is the final architecture. Then exclude the first layer. For the other layer, we applied the input layer. For the other layer, we applied this kind of decomposition and compare the original architecture with the composite architecture. Notice that the memory cost, our constraint was the memory cost and the test accuracy, and also the number of parameters of the network. So the test accuracy have a little drop but negligible, and for the other parameter, the decomposed network is the winner network. So we applied this network to the device in this way. Okay, so this is the network first realized in Keras TensorFlow, so on a PC, and then converted by the TFLI quantization, and also the custom quantization realized by the algorithm, and then realize a firmware in C++ by the help of the STM32CubeI tool, and so flash the OpenVCAM set board. This is the simple integrated development environment to visualize what happened in the demo phase. And the final, this is a little video that show that this color red, this blink notify that the classification is correct. So no feedback about the healthy leaf, and a feedback that then bring to a comment to an actuator when it recognizes a leaf affected by the ESCA disease. The result, sorry, stop the demo. Then we tested also this, sorry, okay. We also test this demo not only with the leaf on a table, but in a real situation. But I don't have the video. Sorry. This is the final result. We compare for security. We compare our result with the state-of-the-art network and obtain the best result for our implementation to validate the effort of this compression and the validity of the AGI application. So this is one field of application, smart agriculture. Another field we focus on is autonomous supervised guide, and we work in this field in two ways, both in the terms of object detection, so detecting the bounding box, the coordinate of some classes related to autonomous guide, so pedestrian, rider, other car, motorcycle, etc. But also in terms of semantic segmentation. Semantic segmentation is similar to object detection algorithm, but it classifies image at pixel level, sorry for the typos, associating a label or category with every pixel in an image. And it is used to recognize a collection of pixels that form distinct categories. For example, autonomous vehicle, like in this case, needs to identify vehicle, pedestrian, traffic, etc. And is used in many applications, also in medical imaging and industrial inspection. So we use the same hardware, Raspberry Pi and NVIDIA Jetson Nano 2 GB. Based on ARM Cortex-A, and the NVIDIA Jetson also equipped with an embedded GPU. And we in the first implementation, we realized, not first, but is parallel, in one kind of implementation for the detection of pedestrian. We modify the YOLO architecture on the well-known YOLO network, using also in this case a technique, a quantization technique. sorry, ecco. So with training, we choose an implementation. YOLO have a lot of version. This paper is recently, but have a long period of revision time, and we use at the time for the first implementation the YOLO version 3, tiny YOLO version 3 darknet. We work on this network. We apply the target decomposition. We apply the fine tuning to adjust the final accuracy, or better the MAP, and we have the final low rank tiny YOLO version 3 darknet. That is our final network tested on these two platforms. And the difference is obviously the number of FPS, because in the Raspberry we have only the CPU, and we add to have an acceleration for the FPS, a TPU, a tensor processing unit, that is an accelerator developed by Google. But obviously with CPU the FPS increase. In both cases, the inference time, the FPS, are measured than of the state of the art, and about the accuracy, better the MAP, we have result in line with the state of the art. In some cases, a better result respect of the state of the art. We make the similar approach, substituting the YOLO and using the UNET, that is a network that was first elaborated several years ago for biomedical application, but actually used also for other application and in general for semantic segmentation. In this case, we implemented not only the CP decomposition, but we apply an iterative compression fine-tuning technique. So a kind of polling of a loop for this compression and fine-tuning to obtain the desired result, and continuously monitoring the the memory occupancy of the network. In this case, we use, sorry, I don't specify. For the autonomous supervised guide, we use the Kitty dataset. This is a well-known dataset for the recognition of pedestrian and other classes about autonomous guide. And for semantic, for semantic segmentation, we use the CanVD database that comprises 32 semantic classes, but typically in literature are used 11 foreground classes, so bicyclist, building, car, fence, pedestrian, pole, road, sidewalk, sign, skin, and tree. This common used in illitera, and this better reflect the statistically significant classes of the dataset. Also, in this case, the hardware is the same. This is a visual inspection of the result. This is the input image, the ground truth, so the true result, and this is the result obtained with our network. Also, in this case, compared with the other network of the state of the art. So, smart agriculture, autonomous guide. Anomaly detection. Anomaly detection is an important task that recognize when a signal has deviated from its normal behavior, and are usable in many applications overall for industrial application, for industrial predictive maintenance system that can recognize when a motor has started to break down or other application. Focus on industrial application. We work in on this application, on this task. I try to synthesize this slide. It's very rich. Okay. So predictive maintenance. I make a little. So the predictive maintenance different from preventive maintenance because it relies on the actual condition of equipment rather than average or expected life statistic used to predict when maintenance will be required. So machine learning approaches are adopted for the definition of the actual condition of the system, including the capability to detect anomaly. And in this case, we focus on oil leak detection, and these leaks are dangerous and hard to inspect manually, but the closed generator cabin is ideal for image-based monitoring. So the system monitor the shaft breaking junction of the wind turbine generator where oil leak typically occur using 4 camera for 360 degree, and we propose a deeply quantized anomaly detector based on a block-based binary shallow echo-state network and a low complexity reservoir computing model suitable for the deployment on low power MCU. The model uses binarized images and 1-bit quantized weight and activation to enable efficient online learning. The system is this. This is the position of the camera, so the installation of 4 cameras framing the junction where anomalies can happen, and this is the anomaly, some example of anomalies at the junction. And block diagram of the camera framing the junction being synchronized in time. This is the final system. Particularly, the flow is this, so camera, anomaly, image with the anomaly, the network integrated into the MCU, and the computation implemented in the MCU for the final response, normal and anomalous. So block diagram of the system architecture from the image acquisition, first step, to their classification as normal or anomalous, and the output of the neural network are evaluated with a decision process called evaluator, which work on the reconstruction error between the network input block and the output block, mediated over all the block in an image. Specifically, the error metric is the number of pixels that are reproduced wrongly. So this is the metrics we adopted to evaluate this system, the validity of this system. So another example, I make all example about image. So in this previous example, I used all only image, but AGI is capable to work on all kind of signal, and so I had also this example is a classical classification implemented by, in this case, not a CNN but an RNN, a recurrent neural network, because we use the input of the network is a time series classification, not an image classification. So time series, because why time series? Because in this work the target is the human activity recognition by the use of, by the acquisition of the photoplethysmography PPG signal. Photoplethysmography is a non-invasive optical method widely used in wearable for heart rate monitoring, but this signal is hardly affected by motion artifacts. So this work target human activity recognition directly on device by implementing a lightweight recurrent neural network that fuse PPG and accelerometer data to mitigate these artifacts. And the RNN is optimized and deployed on a low-cost CloudGem L4 platform that is a platform based on a STM32 MCU, Cortex-M, so low power, low cost, achieving over 94 accuracy with minimal computation and memory covered, enabled so a fully autonomous, wearable, automatic activity recognition system. This is some screenshot about this project. We conduct this project with a group of students. So a curiosity is that some of these projects are research projects in combination with companies or other departments of our university, but there are also a lot of projects that we make with the student during the course. At the end of the course, there are a lot of curiosity about the student with this new argument. So not the standard embedded system, but the intelligent embedded system. So in the screenshot, there is the hand of one of my students, and we measure. We create a custom data set acquiring the PPG signal in different conditions, step, squat, rest, and we realize a custom network implemented into this board. With the help of the STM32 we developed the network realized in Python into a binary that can be integrated into the MCU. The result report different. This is the architecture of the network. The simple architecture of is a very simple architecture of the network, but we make a lot of experiment about the length of the window, the sample weight, the decimation factor, and we make this simulation on PC and then the real validation on the MCU to test our constraint, so the test accuracy, the RAM usage, the flash usage, the Mac operation, and the CPU usage. And there are and these tests are was made also with the classical 80-20 split of the data, but also in a more realistically one subject cross validation to simulate and test a real usage of the device. And thanks for your attention. I stop the screen and I'm here for question.
Thank you so much, Laura. This was a very interesting and very insightful presentation with loads of real-world examples and a lot of very detailed sort of real-world applications you're exploring with your team. I would like to now open up the floor for questions. There's a hand raised, Mohammed.
Thank you, Suhaib, and thank you, Tiziana, Danilo, and Laura for the interesting presentations. So today you covered a lot of interesting topics on embedded systems, cloud and edge AI, computer vision, time series analysis, and a lot of applications in smart agriculture and so on. So I'm here taking the voice of a fresh grad, aspiring to delve deeper into the topics that you presented today. What are the skill sets that you think a fresh grad can work on to equip him or herself with to join your teams, for instance? So the question actually is twofold. What are the basic skill sets that they need to be equipped with, and what are the exceptional skill sets that you cannot easily find and you are always looking for? And this can be, of course, answered from the industry, from the academia, and also from IEEE, how IEEE technical activities can help in equipping such aspiring fresh graduates.
Thank you, Mohammed. I believe this was an open question to all participants, all speakers.
Maybe I can
yes, please,
start
Danilo.
from an industry point of view. Currently, and I can reply by using the examples of the students which are working with me. I see two opportunities in the sense that depend if the person would like to become more proficient on fixed AI or generative AI. I strongly recommend generative AI, taking the challenge I was mentioning in my presentation. And this is what is happening with some students I am supervising. We are trying to devise models which are and optimize models which are deployable at the edge, and also both from a perspective of use cases which can be meaningful, which can give an example, a meaning of generative AI without overlapping with the many use cases that are available on fixed AI. So designing the workloads and the tiny workloads and designing use case, but from an implementation point of view. And obviously measuring quantitatively the deployability cost such that the process of devising and deploying at the edge is simultaneous and by construction. So this is from one side. So I would strongly suggest to go in direction of generative AI because it will be the source of innovation in the coming years, and is already happening. In terms of programming skill, Python, certainly, object-based Python, be fluent with deep learning framework programming. I think PyTorch, there is an increase in demand in PyTorch and an increasing number of examples, and be able to manage Hugging Face model. In terms of soft skill, it's of paramount importance, very, very important, to be interested and motivated. Even if the project is brilliant in its goal, interest and motivation can enable people to go beyond the current knowledge and to acquire new one, and also be part of a team. It's because these are too complex projects that one cannot do in isolation. And seek opportunity in industry, but not because these are opportunity per se, but are opportunity because allows the person to acquire skills which will be fundamental in the future project, in the future projects beyond the one that will be addressed during the internship, because maybe it will last 6 months or 9 months, depends, no? But then you need to really consider that as a place where learn, experiment with the precise project to be addressed, but to enable the future application of the skill acquired, and also the related growth.
Thank you so much, Danilo. Any other thoughts on the question from anyone? Wonderful. Thank you so much, Mohammed, for this question. We have another raised hand. Tony?
Can you hear me?
Yes, we can.
Okay, excellent. Thank you for the interesting presentation. It was you had a very large number of different applications, and you have developed different systems to detect or monitor and collect information. I'm just wondering how much of or how little of an effort it is compared to developing the system, collecting the information, whether it's visual information or sensory information of other kinds, then what comes to making decisions based on this information, whether something goes wrong, pipe is leaking, how do you detect a leakage from serious leakage or just if it's condensation of water on top of the pipe and nothing to be worried about. How so this must be another field that goes a lot of time and research also to make decisions based on your the data that you collect. Is this something that you work also in these projects? Obviously you do, but can you elaborate on that part? How do you make decisions?
I don't know, Laura, do you want to elaborate? You want to go first?
Okay, sorry, do you refer about the collection of data and difficult about the
Let's say,
collection?
for example, the data with the pipe. You had 4 cameras pointing on that, and you saw leakage there. And just wondering that how do you make, obviously that's the purpose of that system is to set an alarm that now there's a leakage in the pipe. But how do you make the decision of sending the alarm based on that system that it's not a false alarm? It's something that you probably detect. It's condensed water on top of it or something like that. So you.
So
What I'm after.
Sorry, the schedule to arrive to a decision is fundamental the same because we start from acquire or use existing data set that are related to the task we need to perform, and then train, test, and optimize the model for the MCU. Sometimes the effort is localized. Sometimes the effort is localized obviously on the optimization of the network, but also on the data processing, because if the data set is already online, it's more simple. But if we acquire a custom data set and particularly not for image but for time series is a very difficult task because we need to decide how many data, how sample the data, eliminate the noise, so introduce filtering and so on. So sometimes we think that the difficulty is only on the network, but a lot of time the difficulty is first previous the network and about the data, because if the data are well categorized, are well defined, and the noise is reduced and so on, and well labeled, because
Yes.
these data must be labeled, and for classification is simple, is a simple tag. So we have, for example, in the smart agriculture, we work in the first demo, as I already mentioned, classification of healthy and unhealthy leaf. So the tag is healthy and unhealthy. But now we work on localize and classify these leaf. So there is another label that is the geometric label, the bounding box that contain this label, and this is not simple. So and it's very important because if we wrong this label, also the best network never work better with the corrupt data. So the scheduling is, as I already mentioned, the same, but there is a series of tuning of preprocessing of method that incorporate in the pipeline. I don't know if I respond.
Yeah, actually, yes, that was quite to the point. Then the follow-up question is, how do you produce this data then that you used for teaching these algorithms, and how much data do you need to teach the algorithm to recognize an anomaly from a normal situation?
How I produce this data? Sorry.
Yeah, and how much data do you typically need?
For image data is very simple. Typically, we establish a campaign of acquisition data. For example, in the smart agriculture, we go to the field of the grapevine leaves and take photo with the same resolution for all the image, the same device to fix one parameter. For the time series, especially for biometric application, is more difficult because we need the agreement, because our personal data. So when there is also in this case acquisition campaign with a protocol for acquire the data from student or researcher or other volunteer, but we need an agreement for photograph leaves. Obviously, agreement is not needed. So it depends of the data. For biometric data is necessary.
But for example, if we're talking about the leaf data, the easier one, how many pictures do you need of different types of leaves in order to this function to work reliably?
We acquired, sorry that I match, I have the document, so I check on the fly.
Hundreds, thousands, tens of thousands, hundreds of thousands of images. What are we talking about?
But see, in the order of 1,000, and if we don't arrive to this amount of image, we apply that augmentation, because with the order of 100 image is too poor, like as a value. So we try to acquire, in this case, 40,000 image, 40,000 image, and apply also data augmentation.
Right.
For data augmentation, because also for a more realistic situation, not only to for augment data, but also to apply some condition like different condition of luminosity, blurring, that is so situation that normally a user have when shoot a photo. So we apply that augmentation not only for augment data, but also to introduce realistic situation, realistic condition.
Yes. Okay. Thank you. Very interesting.
Thank you for the question. Yeah, thanks.
Well, wonderful. Thank you, and thank you so much, Tony. I have a question. This is quite a fascinating topic, and although it's not my area of expertise, it sort of takes me back to the discussions around cloud computing and edge computing as well. And just a quick question, and Laura, you just mentioned about sensitive data as well. As more and more decisions are made at the edge, do you have any thoughts on the security and privacy of the data, and how do you ensure that the security and privacy, considering this will be at the edge in the device?
The privacy is the most problem that leads to the choice of the edge AI solution, because if the data was streamed to a third-party server or a proprietary server, so the data are online, so we can I make perhaps a stupid example, but an hacker can take this data, can manipulate this data, and there is a trace online of this data. If these data are acquired and immediately processed into the MCU, into the microcontroller unit, the privacy is guaranteed by two-factor. The main factor is that there is not sufficient memory. Is the simple reason that guarantee the privacy, because this device has obviously memory occupancy lower with respect to a server. So we acquire the data, we process the data, give the data at the input of the network, and then discard immediately this data. So we guarantee privacy for two reasons. First, this, and then because there is very difficult enter in a firmware that is a closed system written in the memory location of the flash memory. So for these two reasons, the privacy is guaranteed. Sometimes we have for big data, we can try also hybrid solution. So we make a processing on the edge, extracting the feature, and then eventually stream this feature. But from the feature, we don't the user cannot reconstruct the original signal. So there is another solution that I don't mention in the presentation.
Wonderful. Thank you so much. I think Tony has raised his hand.
Yeah, this is a very active topic of conversation right now, and it's not by any means my field of expertise, but this security of information that is at the edge is very topical at the moment, and this is actually there's an initiative in EU to come up with some sort of standard for the development of devices in the EU, and they are talking about that at the moment this security takes place at the software layers of the devices, and this is not sufficient. It needs to be rooted down to the hardware level, and they are some talking about this kind of root of trust procedures that are implemented at the chip level, so that this hardware somehow, which is not fully clear to me, but verifies all the levels of software that's runs on it, so that it's everything is legit and nothing's been altered, and this is the way to secure the security of the information that is needed at the edge. So we need to transfer that in the edge, but it's done there safely. That's like I said, it's ongoing work, and we will probably hear more about it quite soon.
Yeah, we are. Sorry.
No, please go ahead, and then I'll.
To make more secure the elaboration on the MCU, we work also, and Danilo and I call Danilo for help with to watermarking algorithm. So we introduce a kind of cryptography into the MCU, and we published a couple of papers about this argument and this work in progress. So for this reason, I don't introduce this argument in the presentation, but there are the two arguments that I mentioned before about the privacy, but for measure security, we also integrate a second neural network that check the intellectual property and the privacy of data and the network are secure, and is another research field active and from recently active on we still work. future result on the next webinar.
Yes.
If you invite me.
Of course, I
Yeah,
think this
excellent
conversation
topic for the
needs
following
another.
webinars. Yes.
Exactly. Just a quick question, Danilo, for you. I recall seeing in your slides the mention of that the semiconductor companies almost need to do a U-turn to focus because of the growing use cases of Edge AI. Are you seeing that happening on the ground, really? Are the semiconductor companies looking at this here, carefully as part of their roadmaps? And do you see that shift happening more and more?
Sorry, about
Yeah.
the company interested in this topic, if okay. Obviously STM Microelectronics, and but in general, apart the name of the companies, I have several contact with international companies that contact me, but other researchers that work in this field, because are all very interested to bring their device to a next level, to an introducing intelligent function, other function, like I mentioned in the presentation. So from a small company to large company, there is very large request, and also student that between 5 to 6 years ago know only embedded system in their basic functionality, now require me, prof, we can talk about AGI, how I can implement this idea on my device. So there is a large curiosity and interesting from company and also academic and also student about this argument. So it's in arising.
Wonderful.
We
No, that's good to hear. Excellent. Well, I want to say thank you to our speakers. I see, Danilo, you're unmuting.
I'm sorry, so if
No
I
problem.
disappeared, I deep apologize. I had an unwanted interruption at very high level, and I really apologize if I disappeared. Pardon me if for a few minutes. It was
No
unwanted.
problem. No problem at all. But thank you so much to Danilo, yourself, Laura, Tiziana, for your presentations today, for your time and your flexibility as well. And I think based on the questions, I'm sure we'll come back to you at some point, probably for a follow-up as well. This was a very interesting conversation, and we deeply enjoyed that. Thank you, and we'll post
so
the
much.
recording of this webinar on our YouTube channel as well afterwards. Have a wonderful day, everyone, and a good weekend ahead too. Take care. Bye-bye.
Take care. Bye.
Thank
Thank
you.
you.
Thank you.
Thank you.
Bye-bye, Swaib.
Thank you.
Bye.
Bye-bye.
Everybody.
Bye-bye. Thank you.
Thank you.
Hello, hello. Can you hear me?